Hello, this is Martha DeGrasse, here for Wi-Fi Alliance, and this is The Signal, our podcast where we give you the inside track on Wi-Fi. These are meant to be smart conversations with industry leaders. We want to deliver a new perspective on the growing portfolio of Wi-Fi technologies that we see changing the connectivity landscape. Now, in this episode, we'll be talking about the benefits of multi-user MIMO for Wi-Fi 6. And joining us is Rolf Vegt, Market and Technology Development Professional at Qualcomm. Rolf, welcome to The Signal.
Thank you very much, Martha, and thanks for having me on.
Yeah, we're really looking forward to this. Can you start off just telling us a little bit about your role at Qualcomm?
Yeah, so my title is VP of Technical Standards. I work in the Wi-Fi systems group inside Qualcomm. A lot of people may know Qualcomm from being a technology provider for cellular technology like 5G. We're big in 5G, but actually also a leader in Wi-Fi technologies. And I'm in the group that develops all the innovative and new feature sets for the Wi-Fi technologies across our portfolio. And what we deliver then to the market is chipsets that goes into phones and access points that you find in your home, etc.
Yeah, that's really interesting. You're right. We do hear a lot about your company in the context of 5G, but the phones that use 5G and everything else relies a lot on Wi-Fi. Tell us a little bit about how you got involved in that part of Qualcomm's business.
Actually, I got involved in the Wi-Fi industry late 2000, the year 2000, when I became a co-founder of a startup that developed technology called mimo. The startup was called Ergo. We were actually the first company that commercialized MIMO OFDM technology that go into Wi-Fi chipsets. So it is very gratifying that now, more than 20 years later, I'm talking about the next evolution of that MIMO technology in our latest generation of products. So it's been a 20-year arc for where we are now.
That's amazing that MIMO is 20 years old. I think most people didn't hear about it until at least a decade ago. What are Qualcomm's plans for Wi-Fi Certified 6 Release 2?
Yes, so actually, as Qualcomm, we had been shipping in both in our access point products and in our client products a number of the key features that are part of Wi-Fi 6 Release 2 for a number of years already. So we are supporting Wi-Fi 6 Release 2. We're part of the Wi-Fi Alliance testbed. For us, the big benefit of having the Wi-Fi program in place is that it really fosters interoperability. If you had a Qualcomm-based phone talking to a Qualcomm-based access point, a lot of these features, they could be used in that setting, but it really, having a Wi-Fi program around it really expands the addressable market and the usefulness of the technology. So we're very excited about it, big supporters of Wi-Fi 6 Release 2.
Excellent. Okay, let's get on into, this is a mouthful, a multi-user, multiple input, multiple output, multi-user MIMO. For those who may not know what that is, can you explain it?
Yeah, let's first go back.
20 years of work in 20 seconds, right?
It's a little bit of a complex technology, but it has huge end-user benefits. So first off, on what MIMO brought to the market is that what it allowed to do, if you had devices that had more than one antenna, you could multiply the throughput of the Wi-Fi link. So going from 1 to 2 antennas, you could go from 15 megabit per second to say 30 megabit per second. Or if you had 4 antennas on both sides, you could go to 4 times the speed. And that was the key innovation, and it was part of the Wi-Fi, what we now call Wi-Fi 4. What that does, however, if you had, say, and when you saw MIMO entering the market, you saw these access points, they started to look more like porcupines, where you had more and more antennas added to access and routers in the home and so on. So that really drove the increases in throughputs and performance of Wi-Fi networks. But still, if you had a client that's, say, only had one antenna, you would always fall back to the base level of Wi-Fi operation. What multi-user MIMO does is that if you have these access points with many antennas, so for example, our highest end, access point chipset enables 8 antenna systems. What the multi-user aspect allows you to do is that instead of with a normal link, an access point has to schedule traffic to any clients at any given time, so you can only serve one client at a time. In the case of multi-user, you can serve multiple users at the same time. So you can send traffic to say up to 8 clients at the same time in the same spectrum. So theoretically, if you have say cell phone clients that have only one antenna, You multiply by 8 the theoretical throughput that you can get out of a system by using the multi-antenna technology. And that's the key innovation that the multi-user MIMO brings.
Sure. And obviously when those clients have multiple antennas, it just goes up exponentially, right?
Correct. Yes. But it is a resource. Say, what you see right now, if you look on spec sheets of PCs and look at the Wi-Fi portion or the latest generation phones, typically it mentions 2x2 Wi-Fi. Mm-hmm. That means it has 2 antennas or more, but typically 2. And that allows you then to get double the baseline speed. In the case of an 8 antenna access point, and say you talk to 4 really modern smartphones that are all 2x2 systems, you can serve 4 clients simultaneously because you have 8 antennas on the access point and then 4 times 2 antennas on the clients. So that's the basic concept of multi-user MIMO.
And what about the bandwidth for each client? I think we've heard that MU-MIMO makes for a better experience with things like video, gaming, downloading movies on the internet, those types of things, right?
Yeah. So in the Wi-Fi world, when you talk about bandwidth, that typically means the amount of spectrum that you use. Mm-hmm. You have a 20 megahertz channel or 40 megahertz or 80. Right now we're going to 160 megahertz wide channels. That's sort of the bandwidth dimension. And that's one way to increase throughput and performance of system by adding more bandwidth. Initially we call that channel bonding. Really what multi-user MIMO, the dimension that multi-user MIMO adds is that for a given amount of spectrum, say, you're in an enterprise, you only have 40 megahertz of spectrum to deal with. Through that 40 megahertz of spectrum, you can get much more throughput. Because spectrum is the constrained resource. Like in Wi-Fi, we have a little bit of a luxury of the amount of spectrum we have available. But for example, if you look at operators, they have around 100 megahertz of spectrum for their entire 5G mid-band network. In Wi-Fi, we're talking about multiples of that, but it is still a scarce resource that you want to squeeze as much as possible out of, and that's where multi-user MIMO comes in.
Okay, so some very impressive improvements in performance. What are people doing in the real world with all this extra Wi-Fi capacity?
Yeah, that's a very good question, and we get that question a lot, of course, right? We talk about throughputs and speeds and why does it matter in networking. The whole history of the networking, the wired and the wireless industry has been about ever increasing speeds of networks and lower latencies. On the Ethernet side, we went from 10 megabit per second to 102 gigabit per second. Now we're talking about 10 gigabit per second on the Ethernet side. And so why technologies like multi-user MIMO are a way for the wireless side to keep up with those speed increases, especially in enterprise networks where gigabit per second Ethernet networking is the norm. There's a big transition towards all wireless offices. There is a big benefit of not having to wire every cube. If you can just make the same speeds available wirelessly that you normally have to pull wires for, that's a big benefit. Specifically as it relates to uplink, and talking about uplink multi-user MIMO, over the last 10 years or so, we've seen a shift towards initially web traffic was very much, you have a client device, you pull traffic, you pull data from the cloud or from the internet, and then you use it, and then a little bit of traffic goes back. That's really changing. If you think about, your COVID household where people were doing lots of video conferencing and doing their work and then sending up back files into the office. So in the home environment, the shift has changed. If you look in public venues like, concerts or football games where people are there, they want to share what they see on social media. So depending on the environment, some of those big venue settings, it's nearly 50-50. The balance between downlink traffic and uplink traffic.
That's amazing.
And it's shifting more and more towards the balance. It's very environment dependent, but uplink is definitely on the increase in terms of the importance in networking. And that's why having uplink multi-user MIMO added right now is an opportune time.
Opportune for sure. And social media as well. Everybody's constantly, you don't have to be at an event. People upload their whole life sometimes just to tell everybody what they're up to, right?
Yes.
Okay, excellent. So now let's get even a little more technical and talk about the scheduling algorithm and its importance for multi-user MIMO.
Yeah, so the scheduling, you need to have a very good scheduler implementation in your access point. to effectively run multi-user MIMO. And let's talk a little bit of what it takes for a modern access point to schedule the traffic. When our access point, when you schedule, you need to understand what kind of traffic is coming your way, say from the corporate network or from the cloud, that you need to distribute to the clients in your network. So that's one thing you need to know. The other thing is you need to know is what kind of traffic do the clients have in your network that you need to push back into the cloud or into the enterprise network. Those are the kind of things you need to know. You need to know what the capabilities are of all the clients that are in your network. And sometimes there are tens or hundreds of these clients. So you need to understand what each of their capabilities are, how far away they are, whether they're moving, what the stability is on that. So that's the kind of the inputs into your scheduling. Then you need to understand how you're going to push that out. How is an access point going to transmit that to their client? So which clients am I going to pack together into one transmission is one of those things. You need to understand at what data rate each of those stations need to be addressed. You need to check in whether the channel is still stable. So that's where the complexity of a scheduler comes in. As part of Wi-Fi 6R2, we're talking about uplink multi-user MIMO, which is the new addition. And as part of uplink scheduling, you need to basically trigger the clients that all tell you, oh, I've got traffic waiting. You need to then send a trigger signal to all those clients and tell them, okay, send me your traffic. Send it all at the same time and send it to me now. That's kind of how the triggering mechanism works. That's all needs to be part of the scheduling as well. So that's the latest addition, this uplink aspect, and it's a very complex part of multi-user MIMO. And as a matter of fact, the downlink part of multi-user MIMO was part of the previous program. So the Wi-Fi 5. Yeah, it was part of the AC release 2 or wave 2. That's when that was introduced. And it was actually a very successful program for Qualcomm. We got a lot of product sales out of that part, the Wi-Fi 5 wave 2. So what the Wi-Fi 6 release 2 adds is the uplink multi-user MIMO portion. And that's the key innovation here.
And I'm guessing that's increasingly important, especially for some enterprise users, right? With more and more upstream traffic to the cloud and elsewhere, right?
Yes. As Qualcomm, my colleague Ahmed Al-Sharif and I, we did a whole measurement campaign to kind of get a bit of a quantification of what are the benefits of multi-user MIMO. And so what we looked at is a typical enterprise setting where we looked at, okay, you have 3 cube farm. The way enterprises are deployed, you have like 3 or 4 clients per access point. These access points are typically in the ceiling in enterprise buildings. And basically what multi-user MIMO, both the uplink and downlink combined, roughly doubles the throughput of a system from 1 gigabit per second to 2 gigabit per second under the simulations that we did on a heavily loaded network. And that is important for the end user because it really adds, raw capacity to your Wi-Fi network. And in terms of user experience, when a Wi-Fi network gets really heavily loaded, that's when the user starts to experience issues, like it becomes sluggish and slower, the video quality is impacted. I think in gaming, the latency goes up. So those are the kind of things you want to avoid. By increasing the capacity of the Wi-Fi network, you really make the end user experience much better. So that's where it impacts.
Great. Okay, let's talk about educational settings. I'm thinking that this ability of one access point to support more and more clients would make a lot of sense in classroom settings,
yes,
right?
That's another scenario we analyzed, actually, where we looked at a classroom where you had 3 rows of students, 10 clients, 1 access point in front of the classroom. And then we looked at a loaded network and see what kind of increases we could get from using multi-user MIMO. And both in the uplink throughput, we got a 91% increase. So from roughly 950 megabit per second to over 1800 megabit per second. And in the downlink, it was a 100% increase. So from roughly 1 gigabit per second to 2 gigabit per second. So one thing to talk about the multi-user MIMO piece of it, it really is most effective if you have traffic with large packet. So let's say files, upload, downloads, video streaming, all of those kind of things. That's where the multi-user MIMO shines in terms of throughput improvements.
Okay, and sorry if I missed this, but those increases that you were explaining, what was the baseline compared to what?
So basically what we did is we have a single user system, where the access point serves one client at a time. And then we said that's the baseline. And then we turn on the multi-user capabilities.
Gotcha.
And that's when you get the doubling of the overall capacity of the system.
Okay, great. So what about for homes where there are, maybe, well, these days it could be 10 or 20 devices in one home, but certainly not as many as you'd see in a classroom or an enterprise. How does MU-MIMO play out in home settings?
In home settings, actually, our measurement campaign also included a home setting. We looked at a little bit of a different aspect there because the impacts of multi-user MIMO vary based on the distance of the client to the access point. So typically, if you're closer to an access point, the benefits will be higher than if you're very far away from the access point. So the analysis we did on our measurement campaign was we're looking at a home where we had one client which was relatively close to the access point, about 3 meters. We had a client that was about 10 meters or 35 feet away, and there were some walls in between. And then we had a client that was far away, or in a home setting at least, like 20 meters or 70 feet. And for the uplink case, the one that's close by, so 10 feet away from the access point, you had a 106% increase. So the same 1 gigabit to 2 gigabit per second increase. If it was the mid-range, so the 35 feet, 10 meters away, you had a 67% increase in throughput. And then the one that's furthest away was 33% increase in uplink throughput.
That's still pretty good.
It's still pretty good. Yeah, that goes. You go there from 875 to 1164 megabit per second.
That's good. Okay, and what about those big public venues where we all get frustrated when the Wi-Fi doesn't work? Airports, hotels, conferences. Did you test there?
We did not test there. The technology will have its impact. One thing to keep in mind. And that's a little bit different between the cellular industry and the Wi-Fi industry. In the cellular industry, there's a very tight control of, what kind of radios enter the cellular network. In Wi-Fi, people can be walking around with really old phones or tablets, older generation technology and the latest generation technology. It's a mix of all kinds, which is the beauty of Wi-Fi. It always works. It's always backwards compatible. In the case of those really sophisticated features, it makes it a little bit more of a challenge because all those older devices do not support those latest features. And in those, more wild settings like airports and, hotel lobbies, who knows what kind of devices show up. Over time, that will change because there is a replacement cycle in Wi-Fi, maximum 4 or 5 years for portable devices and so on. So over time, that will get better. So we did not do the testing, but where we can project the positive impact is like in the area of like where you have new spectrum, like 6 gigahertz. As an industry, we've decided that for 6 gigahertz, the devices that will enter that particular spectrum are going to be Wi-Fi 6 capable and up. So we do not expect radios that, like 11N, generation radios that would use that 6 gigahertz spectrum. So if the access point is in that new 6 gigahertz spectrum, we know that all the clients also support all these, sophisticated multi-user capabilities. So that's an incremental benefit of going to new spectrum. And then if you have, say, in an airport, some of the access point are using the 6 gigahertz channels, they know that they have all these, more modern clients that will be using that. Then features like multi-user MIMO can be used more effectively. And there will be then an incentive for device OEMs and service providers to navigate, if the clients have those capabilities, to navigate that traffic to 6 gigahertz because they know they have access to those capabilities.
Great. All right. Is there anything else about MU-MIMO that you want to highlight here?
One thing is MU-MIMO is a very important technology in the multi-user toolkit. There's another technology, OFDMA, which was part of release 1, Wi-Fi 6 release 1. It's a very important complement. OFDMA shines for smaller packets. If you really need to reduce latency of networks, that's where you want to play there. Multi-user MIMO is really beneficial in the case of larger packets and really heavy traffic loads. Ideally, you combine those approaches, and that's where the smart scheduler comes in again, to understand where to use OFDMA, where to use MIMO, to which clients, based on the traffic, and so on. So that's an important thing to take into account. So don't look at it as a feature that stands on its own, but it's part of this whole suite of multi-user technologies. That's where it has a role, and that's kind of what summarize it. Yeah.
Yeah, I'm glad you brought that up. For people who aren't familiar, I think OFDMA, orthogonal frequency division multiple access, right? That's about sending more packets.
So both multi-user MIMO is about, and OFDMA are sending us more packets at the same time. It's a multi-user technology. You're addressing multiple users. You only do it in a different way. In OFDMA, within a single transmission, you divide it up and then send smaller packets to multiple clients at the same time. And so say multi-user MIMO will be using the entire 40 megahertz spectrum that you have available, sending that to one particular client. In the case of OFDMA, you divide that 40 megahertz up to say more 4 or 5 clients, and each gets a little piece of that 40 megahertz spectrum. And we call it a resource unit. But in terms of benefits, OFDMA, the key benefits will reduce latency and then also a throughput. But for smaller packets, so voice communication, gaming, that's where OFDMA really shines.
All right. Is there anything else that you want to add related to MIMO?
No, thank you. No, I think maybe one thing I would like to add. Yes. So, we talked about the smart scheduler, about, the complexities of building this technology. At Qualcomm, we are really leading the charge on this. It's a leading edge environment. If you compare, the Wi-Fi industry with the cellular industry, the innovation is happening at roughly the same speed, but the amount of impact that you can make as an individual engineer on the course of technology and the presence in products and markets and people that you use and your grandma uses, the ability to have an impact is much larger in the Wi-Fi industry than, say, in some of the other industries.
Great. Well, thank you very much for explaining that and everything else that you've explained to us today. Rolf de Vegt, Market and Technology Development Professional at Qualcomm, thank you very much for joining us on The Signal.
Thank you.
All right, and that is our show. Thanks for listening to The Signal. The paper that Rob was referencing can be found in the show notes. As always, for all things Wi-Fi, visit Wi-Fi Alliance, that's y-fi.org, or connect with us on social. I'm Martha DeGrasse, and until next time, thank you for listening to The Signal.